Hello friends, today we are seeing about the non-linear regression from the machine learning. Non-linear regression, that is NLR, is any relationship between an independent variable x and a dependent variable y which result in a non-linear function modeled data. Essentially, any relationship that is non-linear can be termed as a non-linear, and it is usually represented by the polynomial of k degrees, maximum power of x. In fact, many different NLRs exist that may be used to fit whenever the data set looks like, and this can go on to the infinite degrees. Now, collectively, we can safely call all these NLRs polynomial regression as long as the relation between the independent variable x and the dependent variable y is modeled as an nth degree polynomial in x. So, what is polynomial regression or non-linear regression? Polynomial regression fits a curve into a curve line to your data. Simple example of polynomial with degree of 3 can be shown. Y minus hat is equal to b0 plus b0 x raised to 1 plus b2 x raised to 2 plus b3 x raised to 3. That's the third degree polynomial regression. It sure likes a feature, a set of multiple linear regression, right? Just like the one below, yes, it does indeed a polynomial regression is. Special case of multiple linear regression with the main idea of how to you select your feature. Common type of linear regression. Before you go on, let's briefly look at linear regression. It is of one equation, y is equal to b0 plus b1 x1. So here, this equation, linear equation models a relationship between a dependent variable y and the independent variable x. This relationship has a degree of 1. As earlier method, there are many types of non-linear regression, but perhaps the most common are cubic, quadratic, exponential, logarithmic, sigmoid, and logistic. First one is the cubic. A cubic function is of the form y hat y underscore hat is equal to interrupt plus variable x raised to the third power of plus x raised to the second power and so on. It could also be in reverse from first power to third power. The graph of this function is not a straight line over the second plane. It's plot one, but first take a look at the cubic equation below. Y minus hat is equal to b0 plus 1 into x raised to 3 plus 1 into x raised to 2 plus 1 into x raised to 1 cubic regression equation. Now, cubic regression equation function is of the equation y underscore hat is equal to variable x multiplied by variable x or raised to the power of 2. Y minus hat equal to b0 plus b0 b1 x raised to 1 plus b2 x raised to 2 plus b3 x raised to 3. Third is the exponential. An exponential function with the base c is defined as y underscore hat is equal to interrupt plus slope multiplied by a constant c which is raised to the power of variable x. See expression as below. Y is equal to a plus bc is raised to x. Exponential might seem a bit confusing, but plotting it is pretty straightforward. Simply apply the numt.exp function and pass variable x as it's urgent in this form. Underscore hat is equal to np.exp of x. Then plot variable x on the x-axis and variable y on the y-axis. Then next one is the logarithmic. In logarithmic function, y underscore hat is a result of applying a logarithmic map on variable. It is one of the simplest expression of a logarithmic function, y minus y underscore hat log of x, logarithmic regression equation. And last one is the sigmoid, that is logistic. It is logistic regression is a variation of linear regression useful when the observed dependent variable y is a categorical variable. It fits a special shape curve by taking the linear regression and transforming the numerical estimates into a probability score using the sigmoid function. That is y cap is equal to 1 upon 1 plus e raised to beta 1 into bracket x minus beta 2. That is logistic regression equation. Hope so all of you are understanding what's the non-linear regression and what will be the representative terms and conditions of the non-linear regression. So thank you very much for watching this video. Please like, subscribe and share my video. Thank you very much.